Oh, here they are. All right, so sine theta is equal to plus or minus the square root of 1 minus cosine theta over 2. Now we said that this theta over 2 will determine if we pick positive or minus. So we look at the original restriction and then we divide by 2, right?
Correct.
So then we got this here. So this is still pi over 2 going to be at second, yeah, it looks like that's now the second quadrant, right? And if you have trouble seeing that, right, this is the same as saying what? 180 less than theta less than 3 pi over 2. Let's go ahead and let me show you the circle, be easier.
Less than 270, right?
Should be stupid. Forgot to install my PDF thing. 1 second. There it is. Yeah. Sorry, I don't have my PDF installed right now. So if we divide by 2, this would be 90, right? Theta over 2 less than half of 270. What will that be? 135. Is that right?
Yeah, that's correct.
Yeah. So now is it more obvious? Which quadrant are we in?
2.
So for sure we're in 2, and sine is positive there, right?
Correct.
So we're going to use this one. So sine theta over 2 will equal positive 1 minus cosine, and we found cosine to be this. I guess I'll use this one. I don't think it's going to be pretty either way. So that'll be 1 minus a negative.
Sorry, it's positive because it's in quadrant 2 because sine is positive in quadrant 2, or?
Yes, that's correct.
Okay, thanks.
So that'll be root 29 over 29. Doesn't look very pretty though. Everything divided by 2, right? So it'll be a minus minus. Change this to a common denominator, so that'll be 29 minus or plus 5 root 29 over 29. All this is square rooted. There's still a 2 down here. So you multiply 29 times 2. Where's that going to be? 58.
Yes.
Okay, so we'll have a 58 at the bottom. So our final answer, the prettiest that I can make it, it's going to be this weirdness. And there's no way I can reduce at 58 that I see. Nah. Check though. Nope.
I'm sorry, sir. I don't know if it's just me, but your paper's a little blurry on my end.
Oh, is it? Let me see if I can fix that. Is that better or is it too far?
Okay. I think I figured out what I did wrong.
You see it?
I wasn't having the quadrants that it was in or whatever, the range.
Oh, you didn't take into account the sign?
No, the angle of what quadrant it is in. I didn't have the domain or whatever.
Oh, I see. So you just went ahead and used the original?
Yes.
I see. Yeah, I think it would. So what did you choose for this the sign in
Use
front?
negative. I use negative.
Okay, so you had everything correct. You just needed the correct sign.
Yeah. Okay.
Okay.
Thank you.
We can do D, or is that?
That
makes
makes more sense to me now.
Okay. Cool. And if we did D, we would choose negative, correct?
Yes, because cosine's negative in the quadrant too.
Yeah, so if we do cosine, go ahead and do it. Theta over 2, that would be negative because of the quadrant 2. That would be 1 minus cosine theta over 2. And that will be...
Minus, I thought cosine was 1 plus.
Yes, that part is true. Thank you. So that'll be 1. So this is going to be negative, so this right here will be minus. Minus 5 root 29 over 29 divided by 2. So that will give us negative 29 minus 5 root 29 over 58.
That's right. Okay. Yeah, I figured out what I was doing there.
Cool. Yeah, be careful with those. Sometimes I forget too, like, which symbol do I choose, right?
Yep.
You guys have any other questions or sections? In the meantime, I'm going to install PDF real quick.
I had a question on the 8.7 homework.
Let me go
What was the last question? 13.
8.7, number 13, you said?
Yes.
All right, let's see if it loads this time. Oh, there it goes. Cool. All right. 8.7, 13.
Yeah, so I looked at the question help on how to like calculate it, but for some reason in my calculator, like I did it like the question help numbers to see if I was gonna get the exact same answer, and I wasn't. So I don't know why. I think I probably calculated it wrong.
No, let's see what happens. Let's check. Okay. Number 13, right?
Yep.
Okay. Almost done loading. I feel like I'm on dial-up right now. That's a weird question. See on a touch-tone phone. Yeah, I did not mean to assign that to you. I'm gonna get rid of that question.
Okay.
Yeah, that is not gonna come up on your test or final. I'm curious though. sorry about that. No, yeah, you're not supposed to be doing that one. We didn't really go into word problems of double angles. Yeah, just skip that. Let me go
Okay.
ahead and delete it. 8-7, number 13.
Is there any more in 8-7 that is similar?
Yeah, let me
No,
check.
it was just that one.
Yeah, it was like a really strange word problem, but you're not supposed to be doing word problems in 8-7.
Yeah, all of the previous ones were really similar, and then I got to that one. I was like, what am I doing?
Yeah, I'm sorry. That wasn't supposed to happen. I didn't catch that. Yeah, it's gone now. Don't worry about it.
Okay, I refreshed. Thank you.
Cool. Okay, someone's requesting question 18 on the review. Let me go look at what that is. Question, oh yeah, it's over here. Review number 2, number 18. Okay. Was this question. It says, use the information given about the angle. Let me move this real quick. That the angle theta, where theta is between 0 and 2 pi, find the exact value of the following. So it's similar to the one we did before, but let's go ahead and do it anyway. To give you the tangent, then they say that theta is between pi and 3 pi over 2. And they ask us to find sine of theta over 2. So the formula is still the same. 1 minus cosine theta over 2. So we need the triangle to find the missing piece. So that'll be, this theta is here, opposite and adjacent. So C will be, what, 13? Let's check. No. 15, oops, I messed that up. 15 squared plus 12 squared to the square rooted. That will be square root of 369. Okay, I don't think that reduces. Well, maybe it does. There's a 9 in there. 9 times 41. So that would be 3 root 41. So 3 root 41 is the hypotenuse. Okay. So all I really need is cosine, right? Cosine theta is equal to, this is quadrant 3 still, right? So cosine, they're both negative there. So minus adjacent over hypotenuse. Then that will reduce into 15 divided by 3, that's negative 5 root 41, which is negative, I'll do it down here, negative 5 root 41 over 41. And if I divide this by 2, on the last example, we said that's going to be quadrant 2, right? So I'm going to choose the positive because of this. So then,
When you got the hypotenuse, what formula did you use to get 3 square root of 41? Because I got 13. So I think that's where I messed up.
yeah, I thought it was going to be 13, but let me double check. I feel like it should be, but it wasn't. Because a squared plus b squared is equal to c squared, right? So c should be the square root of these two. And you got 13 here?
I got 13. I don't know how.
Let me check. Maybe I messed up.
3 square root 41.
Yeah, I'm not, it's, yeah, I don't think it is 13, right? With this,
Isn't the hypotenuse always the longest side? So it couldn't be less than 15, right?
yeah, that's true. Sorry, you're right. Good. That's big brain thoughts right there. Thank you, man. Okay. Yeah, it's not 13. So theta over 2 is going to be positive. So 1 minus cosine. So 1 minus a minus will be plus eventually. But I really wanted it to be 13 because it looks like one of the magic triangles, but we needed 13 here, and that would be 15, but it's not. So we just gotta let it go. Just let it go. All right, so negative 5 root 41, that's right. Yeah, so then that will become 41 plus 5 root 41 over 41 times 2. So when you combine these two and then divide by 2, that'll give you an 82 here. That is as pretty as it's going to get. Is there any questions about any of these steps?
Which one would be the answer for that one then on the actual practice test?
Oh, let me check. Right, we do have answers. Let me turn on the answers because I can't see them. 18 should be. Man, this doesn't match up at all. Oh man, I wrote 15. It's a 5. There's no 15 there. Man, that
Yeah,
messes
smart.
the whole thing up. So I made up a question that was not on the test. It's on the review, I mean. It's similar though. Let me fix it for you.
I didn't even notice you put 15 instead of 5.
Yeah,
Yeah, that makes it 13.
yeah. Now we get
I feel
13 that
better.
we wanted. So somehow, so I did this part right, but yeah, let's fix this. I hate when I make a mistake right at the beginning. It messes everything up. Okay. So that's 13. So then this is going to change. It's going to be a much prettier question. These will change.
Your tangent will change also.
Yeah. That's correct. 5. So 13. Cosine would be 5 over 13, but negative because it's in the third quadrant. So all this is fixed. So then when we plug it in, this would not be right. So this would be negative 5 over 13, which is much prettier than what we had earlier. So that'll be 1, so 13 plus 5 would be 18 over 13 over 2, which is 18 over 26. So now we reduce the square root. And I think we should get it. There is a 2 times 9 here at the top, and a 26 down here. 26 does not have any squares though. No. But it does have a 2. I don't know why I put 19. So 18 is 2 times 9. So that cancels these 2's. Square root of 9 will be 3. So we get 3 times 1 over 13, which is the same as, well, actually that's kind of a weird way to say it. That's not wrong, but I don't like that. It should be, you should think of it this way. I'm square rooting the top, so I'm left with 3 over root 13, which then gets us to rationalization of 13 over 3 times root 13 over 13. There we go, finally. So it's going to be D. So the question was a lot easier than I made it out to be. But is there any questions if I'm to confuse you because of that? Let me know. And the process is the same. I just changed the numbers.
So what letter is that? Does it match up on the review?
D.
Thanks.
Okay, next question. 13 on 8.5. Oh, one moment. Okay, number 13. So these are not unit circles. Well, alpha is not a unit circle. Okay. Okay, so it's similar to what we've done before. The only thing is they try to throw a wrench in the whole problem by not using a unit circle for one of the angles. And I'll show you what I mean in a second. Okay. So they give you a function. They say, let's call f of x equal to sine x. Then they say find, well, basically they're saying find f of alpha plus beta. So they're really saying the sine of alpha plus beta. So we'll use the formula for the sum of angles to start with. Let's find it.
I can read it off if you want.
No, I found it. Thanks. Jess got it. But double check me though. Is this right? Sine alpha cosine beta plus cosine alpha sine beta. Is that good?
That's what I got.
All right, cool. Make sure we start correctly. So we need to find sine alpha and cosine beta, etc., to be able to solve this. So in the question, what they do, let's look at the question. They give us an alpha, but on a circle that's not unit 1. And beta is unit 1, so that one's whatever. But these are not known angles, so we'll have to find the missing pieces. So for any alpha function, so sine alpha and cosine alpha, I'm going to have to use the definition. This is like the very beginning of, I think, the class maybe. We had cosine defined as x over r.
Can you
sine?
can't really see what you're writing.
Okay. You want to zoom in a little bit?
Hold on, maybe I can just pin your camera. Nope. It's just because you're zoomed in on the question.
You're sharing
Right,
screen,
right.
so we see it.
I forgot. Sorry. Y over r. So remember how we define it this way, where it's a general function where r is not 1. Because on the unit circle, right, cosine is the x value referring to an angle. We said sine was the y value, right? We've been doing that for a while. It's just that R was always 1, but it doesn't have to be. So we need to find,
okay.
so now in this circle, it's saying that R is 4. Well, actually R is 2, because it's x squared plus y squared equals R squared. So R is going to be 2 for that picture I showed you. So, and they gave us the x, so we need to solve for y. Oh, actually, they gave us y. So we're going to use this formula. We don't know x, but we do know y is 1. We know R is 2. So x would equal to R squared minus y squared square root, which would be the square root of 4 minus 1. We got x and we got y, right? So now we have cosine alpha as square root 3 over 4 and sine alpha as 1 over, sorry, actually 2, not 4. R, we said it was 2. Okay, so now we got to find the cosine beta and sine beta before we start.
Isn't one of them given already?
Yeah, pretty much. Let's look at the thing again. Because this is a unit circle, so we don't have to worry about R. So we have x, right? So
Yeah.
the cosine will be this. We don't have to divide by anything. But we do have to solve for y on that one. So for beta, so we're going to make a note here so it's not all confusing. This is all the alpha stuff.
Or share your screen, unshare your screen.
Yeah, 1 second. Okay, so this is me solving for the alpha stuff, and I'm going to start the beta here. So I don't know why, but x is equal to, let me write it the same way for consistency. We don't know why, but we have x, negative 1/3. Y we need, and R is 1. So x squared plus y squared is equal to R squared. So this would be negative 1/3 squared plus y squared equal to 1. So y will be the square root of 1 minus, it looks like it's going to be 1/9. Right? So then that will be 9 over 9 minus 1 over 9, 8 ninths. There we go. So 2 times 4 over 9, that would be, square root of 4 is 2 over 3 root 2. All right, it's not very pretty, but it's a little bit better. Okay, so we have y now, finally, right? So 2 root 2 over 3. So now I have sine beta, cosine beta. So since it's a unit circle, we just take the x and y values. We don't have to do anything extra. This will be negative 1/3. This will be 2 root 2 over 3. So now we just plug it into the formula and you're done. You plug it in here, and that's it. So the answer, all right, I'm gonna try to make a space here. I'm gonna try to divide my steps so I'm not confusing people. So found the sine, cosine alphas and betas here. The question is really asking for this, but it requires all that stuff, okay? So now we can answer the question. Sine alpha plus beta will equal sine alpha, which is 1/2.
Can you move your paper up a little bit?
Yeah, let's see here.
Thank you.
1/2 sine alpha cosine beta is right there. Negative 1/3. Plus cosine alpha, which is here.
Wouldn't your cosine alpha be negative since it's in quadrant 2?
Oh
the
yeah,
first-
good question. Let's see here. Alpha x should be negative. Yes, that's right. Yeah, so when you do the square root, technically there's a plus or minus here. So you'll select minus because cosine is negative there. That's true. Sine is positive there, and for beta, they're technically both negative. So this should be negative as well. Yeah, so then this one is negative. Last one is sine beta, which is a negative 2√2/3. So that'll be negative 1/6 plus 2√6/6.
Sorry, why was the sine beta negative?
Beta, oh, if you look, let's look at this picture real quick. I don't want to draw crappy pictures, but
Oh,
beta's
okay,
in
sorry.
third quadrant.
I was looking at mine and I thought you were, never mind. My question
Yours
was different. Yes, but that's fine.
Oh,
I get
okay.
it.
Was it the similar numbers or completely different?
It was different angles. So like my angle ended in quadrant 2, yours ended in quadrant 3. So I was just
But
looking at mine and thinking you were sharing your screen or something. I don't know. Don't worry about it.
No, that's fine, man. No worries. Okay. So that's pretty much it. At this point, you can add them together. But you guys have any questions on this? Does that make sense?
For my question, my alpha lands on quadrant 2. So would it be different?
Your alpha was quadrant 2.
Yeah.
So on that one, cosine would be negative and cosine would be positive. No, sorry, other way around. No, they'd be the same. Because I think this one was also quadrant 2, wasn't it?
No, you're in quadrant 1, I believe. Oh no. Wait, let me check mine.
Let me
yeah.
go back.
Mine was in quadrant 1, yours was in quadrant 2.
For alpha, let me show you. For alpha, it's quadrant 2. So my x will be a negative. My y will be positive.
And if it was in quadrant 1?
They would both be positive for cosine alpha, sine alpha.
Okay.
Thank you.
All right. Yeah, now also number 20 on H5, I'll get rid of that one too. Let me go through that now. H5, number 20. Okay. Or any other questions you guys might have or been struggling with?
Do you want us to do number 20 on 8.6?
Which one was that?
On 8.6, number 20.
Let me see. Hold on, it's loading really slowly. Eight point six. Number 20, you said, right?
Yes.
For this question that you worked out, is it 2 with the square root of x, or is that an 8? I can't tell.
That's a 6. But you're gonna do 3 times 2, so it'll be 2 root 6
Okay.
over 6. And no, no on the 20. It's not gonna come up. It's fine.
I haven't attempted it, but number 19 on the same one has like apothums and solving for area of an octagon. I don't know, but it might be easy. I just haven't attempted it.
Let me look at it. I don't want you guys to do homework that we didn't cover. So hold on.
Very long and nasty.
On 8.6.
Yeah, or 8.5. 8.6 or 8.5.
Yeah, I see an octagon.
There was a decahedron or something like that on 8.5.
Yeah, I messaged him about that one. He took it off.
I did it, but I had to follow the example question to do it.
I see. Yeah, they're gone now. No worries. Oh. But maybe I'll give you some extra credit for suffering, Philip.
Yeah, I was gonna say more power to you for suffering through that.
You deserve bonus points. You guys have any other questions? Or concerns over the homework?
What questions did you say you took off?
I took off 19 and 20 on 8.5, and I think 20 on 8.6, or the last one on 8.6. Yeah, on 8.6, 1920, and I think 8.5, 1920.
Took off 8.7, number 13 as well at the beginning of all this.
8.5? Yeah.
No, at the beginning, someone asked about 8.7, number 13, and you took it off. I was just answering your question.
Thanks. Gotcha. Yeah, I forgot about that one. That's true. All right, guys, you have no more questions then for today? Guess you're
I don't.
Good.
I have a question on 8.5, question 12.
8.5 question.
I don't know if you went over it.
Let me see. We've done something similar, but we can do it if you like. Was it part A or B, or do you remember?
I just clicked similar question right now. Let me see. I don't remember.
Okay. Let's see here. So they give you sine and cosine. Let me show you the question. So you have sine, cosine, and then they tell you that alpha is between 0 and pi over 2, which is quadrant 1. Theta is negative pi over 2 to 0, which would be quadrant 4. They just wrote it in a weird way.
Oh, okay.
So then you have to find cosine beta and cosine alpha and sine beta to be able to answer these three here. And then
Okay.
tangent, you'll have to find the tangent of each of these. Do you want to do part A?
I have different numbers in that one.
I mean, if you want to do yours, that's fine too.
Yeah, I would prefer that.
What is your sine alpha?
It's 4/5.
Sine alpha is 2 over 5?
No, 4/5.
4 over 5.
And
Okay.
then it's 0 less than alpha less than pi over 2.
Okay.
And my cosine beta is 8 square root of 145 over 145.
8 square root of what?
145 over 145.
Okay.
And then negative pi over 2 less than beta less than 0.
Zero. Okay. So we're going to define two triangles for alpha and beta.
Okay.
So let's see. Alpha is going to be 4 over 5, which means it's 3. It's one of the special triangles, quadrant 1. So they're all positive. So sine alpha is 4/5. Cosine alpha is 3/5. Tangent alpha is 4/3. Now let's find the pieces for beta. So that'll be some nasty numbers, but oh well. Adjacent side, hypotenuse. Find the missing side. So the missing side will be 1 square root 145 squared minus 8 squared times root 145 squared. So A is some weirdo number. Use my, well, yeah, I'm using my calculator here. I don't think that's going to be pretty. Minus 8 squared times 145. That will be the square root of 11,745. That is nice, not nice at all. Alpha will be this, sine alpha, 11,745 over 145. Cosine alpha will be, well, we already have that, but I'll write it again. 8 times square root 145 over 145. Tangent alpha will be this one over that one. After some algebra, we will get square root of 81 over 9, which is 8. 9/8. There. It's a lot prettier than the other ones. Oh well.
It's in quadrant 3 also, right? Or 4?
Yeah, 4. So sine is negative there. Cosine is positive. Tangent is negative.
Okay. Okay. That's how you like we normally would work it out.
Yeah, I mean it's the same as we did up here. Sorry, my headphones disconnected. So it's just that these numbers were not pretty. So just like before, sine is this. So you fill out the triangle, you solve for the missing pieces, and then you define sine, cosine, tangent. The next one they gave you cosine, which is adjacent.
I don't see green. My screen.
Oh yeah, something is wrong. Hold on a second.
Okay, I see it now. Fine.
Sorry about that. So one more time. So the way we do this problem, right? I know those numbers are ugly, but then you just need to understand how we do this. So sine is 4 over 5, right? And then you find the missing piece. Once you get the 3 functions, you can start answering the questions. So you got to find the 3 functions for both triangles using the information you are given. These range of values here tell you where the angle's at to tell you, that way you know which ones are positive or negative. Okay? Since this is quadrant 1, everything was positive. Since this is quadrant 4, y is negative, and so is tangent. Once you have all the missing pieces, you just plug it into the formula, right? So the question was sine alpha plus beta, right?
Yes.
So we just use the formula, which was something. Where did I put that guy? I wrote it earlier. Okay, so that'll be sine alpha times cosine beta plus
In our
cosine alpha sine beta. What's up?
in our example, we're going to want like formulas like that on
So,
our whenever we work through it.
you mean, are you asking if you need to write it each time, or what do you mean?
Or yeah, like if I think it was like partial credit, right? In our last exam, if we put like some formulas.
Yeah, if you at least show the right formula and set it up, at least you'll get some good points.
Oh, okay.
But because if you skip steps, then you better get the steps you do show better be good.
Yeah.
So be careful. But once you have all this, you just plug it in, right? Sine cosine. That will be 4/5 times cosine beta, which is this nasty thing over here. Okay, and then that'll be plus cosine alpha, which is 3/5 times that nasty thing. Oh, no. Sine cosine alpha is actually here, right? Sine beta is there. There we go. Negative signs would be on cosine. Oh, I see. That's why I'm confusing myself. I wrote alphas twice. This is actually beta. Not as a minor error, but it was enough to throw me off. Beta. So this one here. Sorry about that. But
That's
you guys
okay.
see the point, right? Just plug them in. Here's beta. This is cosine alpha, which was 4/5, so that was right earlier. Okay. Sine beta, that nasty thing right there. Negative. That's not enough space. Eleven, 7, 4, 5. 1, 4, 5. There you go. Sorry about that. All right, so anyway, just plugged it in, make it pretty, but do you guys have any other questions?
No.
Okay. Double checking some stuff, but I guess if you have no other questions, then we'll stop here, and I wish you the best on your exam. And we'll start some new stuff on Monday.
Okay.
But let me know if you guys get stuck or anything. All right, we'll see you guys Monday.
Have a good night. Bye.
Good night.